Hi lads, in this video I'm going to go through how to the 4 methods to find the true shape of an object on an oblique plane. So basically, what does the true shape of like a triangular laminar look like? So in an elevation of the plan we don't actually have a true shape of it because the plane is resting on an angle. For example, like a plane inclined like this. We can't actually see that true shape unless we have it flat down the table, then we can actually draw our outline using our true lengths. Because in the oblique plane it's always tilted at a sort of an angle to make it look a bit more squashed. So the first method we're going to look at, well the first two are basically the exact same one, just different ways of doing them, is called rebattement of the plane. Basically where we take the plane, for example like this here, say that was the triangular laminar there, and this was the oblique plane. We take and rotate it around to flat down on the table so we can actually see the true shape of the triangular laminar then that's left behind. So it's almost like this line here, which is going to be our horizontal trace, like a hinge, and it just rotates around like that. So in the actual picture I've given you from the book, there actually is no measurements. So what I'm going to tell you is that the vertical trace is going to be at 30 degrees, and the horizontal trace is going to be at 45 degrees. So just put it in there, 30 degrees and 45 degrees there. As you know yourselves, just any length at all to them. If you find your question sticking out a bit more, extend the trace then as a result. And in the question you can see there is a triangular laminar and plan. And I'm just going to roughly position. I'm going to say that point A is going to be there. I'm going to say point B is here. And point C, I'm just going to put that like down there. So I'm just guessing it completely. It doesn't make a difference where it is. And then I'm going to connect those together. And there's my triangular laminar then. Next thing you need to do is find an elevation. So remember, take your points parallel to your trace. So for example, A goes parallel to our horizontal trace there, goes up to hit our vertical trace, goes across, and where A goes up there, we get point A in our elevation. The exact same for B and C. So I've just made sure that B and C will have their own unique lines that are not just parallel to each other. And just take B and C up together at once there, just to speed up this part. So you can see C there, it's going to be there, and B is going to be there. And then we connect A, B and C together there as well. So there's our elevation and plan of that triangular lamina. Now in both of those views, just say it's something like this, you can't see in either of those views that true shape in there. When we look at the front, it's going to be a squashed appearance. When we look down, it's going to be a squashed appearance. So we need to actually rotate it around, rebat the plane, that when it sits out flat out here, so seeing that I'm using this here as my horizontal trace there. At the moment we have something like this. If you imagine that was your triangle there, elevation, looking in there, or sorry, looking down in plan, looking straight in elevation. I want to rotate that around so that it sits flat like that on the ground, and I can actually see my true shape as a result. So the first thing we're going to do is actually draw our planes. There's going to be our hinge line there. We need to draw our new vertical trace that's going to be coming out here then. So to find that, it's going to be a true inclination basically. What we need to do is take a height, for example here, any height at all, doesn't make a difference, and we'll do is let's use colour to show it as well. So I'm going to take that yellow height and call it H. I'm going to rebat it, so I'm going to rotate it around. So I need to use my compass. That's going to rotate around. For mine it's going slightly off the page, but it doesn't matter. Rotate that around. We then look in perpendicular to our horizontal trace there, from H. And where they cross, that gives me a point on my vertical trace. And we just call that VT1 then. So it's being rotated around, so you can see that there. What you need to do then is, you need to take all of your points around and rotate them. So, A is the first one. A comes across, it hits our vertical trace there. That as our hinge, we rotate that around. So we rotated that around there. And what we do is, we take this out, just like it is here. It's going parallel with the XY line there. This base here, new XY line you could say, or horizontal trace there. That goes parallel there. And where A is, in our plan, we take that out to meet it. So there's A there, there's the new position of A. So once again, I'll just use colour to show that, and I forgot to actually mark in my height H. So my height H there, rotate it around. What I've done is, I just extended that line. So you don't actually take the actual height itself. You're using that line there and you're extending it out here to give you that point. So, just use green just to show A there. So A, take it across to hit our vertical trace, and then it's rotated around. So that's rotated all the way around to hit our new vertical trace, and then that goes across to there, and it stops at the point where A in the plan is taken out perpendicular, so 45 degrees going this way, it has to be 45 degrees going that way, and that gives us the position of A. And that's the exact same with the other 2 points. So B goes across to there, we take that distance in our compass, rotate that around, take it across parallel just like it is here, parallel to XY line there, parallel to our horizontal trace here, and then where B is protected out. Get this point B there. Now we can connect A and B together. So that's actually the true length of AB. That's actual length. Then for C is the exact same thing again. C is taken across to their vertical trace. You rotate C around. Taking parallel then to our horizontal trace. We go perpendicular to that trace. Gives us C out here. And we connect A to C and C to B. That now gives us the true shape of ABC. So basically what we've done is we've taken like that and rotated it out flat on the table, and that gives us our true shape for our surface as a result. So all them lengths are true lengths, therefore we get a true shape as a result. So that's one way of actually doing the rebatment method. So another method then would be taking it this way. If I just repeat the idea again, if I just extend this line out here, and I'll take the exact same plane again. So 30 degrees, take 30 degrees there, label my vertical trace, go down 45 degrees, label my horizontal trace. What I'll do is I'll take my exact points in my plan there again. Oh, sorry, it should be up here. So C is going to be somewhere out here, B is going to be somewhere out here, and A is going to be somewhere out here. All I'm basically doing is I'm going to copy the exact same measurements, just so you can see the same result again. So distance from there to A, same here. So there's A in plan. Distance from B is that distance there, and then C is that distance there. So basically I'm just drawing a mirror image of it again, like this is a copy. And then connect A, B and C together. There's my plan view. And I just project my points up and across again. So A parallel, straight up and across, and then up there. That gives me A, same position. B, and that taken across gives me B here. And C, gives me C out here as well. So now I connect A, B and C together again in my elevation. And just as a reminder, just how do we always do that again? We go parallel to our trace there, we take it straight up and across, and where it stops going across, where A goes straight up there. It's just always keeping it fresh in our heads how we actually find the projections of our points on the plane. So what we're going to do this time is we're going to rebat it again, but just using a slightly different method. So what you need to do is just take a height randomly. Say for example this height here. Once again, because it's going to 45 degrees, we project our perpendicular at 45. And what we do then is we take this distance on our compass, rotate it around this way. So we take our compass and we swing it around this way, and we get a point here. That will also give us our vertical trace. So our vertical trace 1, our new vertical trace line that we're actually drawing. And then what you can do is excuse me, you can then project out your points. So for example, A in our plan, A is going to be somewhere out here. To find exactly where it is, we take a parallel to our our horizontal trace and plan. So this line here that we have in pink, where it hits our XY line, project that out to hit our new vertical trace, and take a parallel again then to our horizontal trace, and that'll give me point A. So you can see, even if I just took them across, you can see A and A are actually on the same line there. They actually line up perfectly there. So that'll give me the new position of A then as a result. And what I'll do is after I get the second and third one done, I'll put in colour how I did it, because I don't want to use A again with the same colour. So B is projected along to our XY line, go perpendicular to hit our trace, so our new trace VT1, take a parallel again to our horizontal trace, and then project B out. And you see if I was to take B across, it will give me the exact same point again. And C, just project out this way first. C projected up to their XY line, project it out to hit our vertical trace 1, take it across, and there's C there once again. So both methods are perfectly acceptable to do for rebatment. Just two different ways of doing it. One rotating your points out this way and taking your heights across, which is shown here. And the other one just basically using the actual planes given here to project points over and across. So I'll just show in yellow what I did there for point C, for example. So C is projected out to my XY line, take my perpendicular, take my new trace, That's taken across, parallel again, my horizontal trace, and then where it stops is where the actual C is projected out to meet it then. So it's just another method of doing rebatment. So just put that there on the actual sheet. So rebatment of the plane. And they're just two different methods. So you have method 1 there, and method 2 there basically. So just two different methods of how to actually do that. And they're the two questions you're going to do in Tuesday's class. And then for Thursday's class you're going to do the next two methods. I'm just going to record them both in the same video, and you can, just as long as you've all four done, then basically for Friday night that's fine. I'm just going to pause the video there while I just turn around the sheet. So then method 3, that's going to be an auxiliary elevation and rebatment. So basically taking an auxiliary and then rotating the auxiliary out flat so you can see it as a true shape. So the first thing we're going to do is we're going to draw our XY line. And in the book, once again, it doesn't have any measurements for this. So I'm just going to take it that we have excuse me, a 30-degree line going here for our vertical trace. And once again, we'll just go with the 45-degree line then below for our horizontal trace. There's our horizontal trace there. And we're going to do the same idea again. I'm just going to pick a few random points here. So I'm going to say A is there, B is there, C is just down here. I'll just label that A, B, C. So none of these measurements actually make a difference, lads, to the question. Once you draw any sort of shape and you draw the elevation correctly then from the plans, or taking your lines up, across and over, your question might look, or your answer might look a little bit different to mine because your shape might be slightly different, but once you carry out the same method I do, your result is correct then. So A goes parallel there, straight up, and take that across there. There's point A, point B, same idea again, and then point C. So once again, just making sure basically that I don't have anything there in parallel, in case people think, oh, that once you draw a line parallel to there it's going to be correct. I'm making sure that my points are sticking out slightly, so I have to draw 3 separate lines for A, B and C when projecting the horizontal trace. And there's C. So now I can connect A, B and C together, and there's my elevation now. So once again I want to find the true shape, and this time I told you I'm going to use an auxiliary elevation and rebatment. So to do an auxiliary elevation, we have to see our horizontal trace as a point. So we can see an edge view of the actual plane, and if we see an edge view of the plane, we can see an edge view of the actual lamina itself. Because remember, the lamina is actually resting on the plane. If you imagine this is our oblique plane once again, there's our lamina, it's sitting on the actual plane. That was an angle this way, and I look in and I see it as a point there. So if I just look in like this, if I just tilt it outside so you can see, I'll be able to see an edge view of them 3 sides there. So that's what we're trying to create. So I extend out my horizontal trace there, and remember our x1, y1 is always perpendicular to perpendicular to our line we're drawing there. So our point view is here, and we don't just take that angle there. That's what some people might actually do, is they'll go out 45 degrees there, say, oh yeah, go parallel now to the vertical trace here, and draw that line then as a result. That will give you a false XY line. It wouldn't be correct, it'd be the wrong one. So remember, the XY line is always perpendicular to the line you're looking in perpendicular to. So if I'm looking in at this angle here, I always draw a line perpendicular to that there. Just put in my perpendicular sign. So there's our horizontal trace as a point. So how do we always find our trace? So a point in our plane, if we take a height line here, that out and take this height here. So a random line there is taken out, go perpendicular to there, we mark that height there. That gives us points in our plane, and now we have our true inclination of our vertical trace as a result. So call that VT1. This height here, let's call that H, the same as this height here, and that was extended from that point there up. So what we're saying basically is our lamina is somewhere on that plane. Remember the same idea again. If we look in this angle here, we're going to see it as an edge view like this, and on that plane there is actually that triangular lamina. And that triangular lamina, if we project up B is there on it, C is there on it, and A is there on it. So I know I've drawn the whole thing in heavy. I'll just use green to show it. So there's our plane there in elevation. Just coloured in green there. So that's our elevation. There's our plan. And our edge view of ABC is only within that green surface there between A and extends out to B there. So now what we need to do is we need to rabat it. So the idea, once again, we're batting it around this way. So we're taking our auxiliary view, now we're going to rotate that auxiliary view around to go from being sitting at this angle here, rotating around to be flat on the table then. So first thing I want to do is extend out my XY line. That's our ground, remember. We want to rotate that around to hit the ground. So I'll just take A out first, for example. A comes out, it's at that angle there, sitting flat on the ground, and projects out, once again, parallel to our horizontal trace, or perpendicular to our X1, Y1 line there. I'll just label that X1, Y1. Where is A in our actual view and plan? It's there. So A comes out to there. B, the exact same idea again. B rotates around flat on the ground, projected out here, and B projected out gives us that point there. And the last one, C. C is rotated around. Remember, that's our pivot point at all times. It's a horizontal trace. If we look in there, horizontal trace is a point. And C is extended out to there. Now, if you were to take the exact same method every single time, or not sorry, the same method, if you were to take the same measurements like I did for the first two sheets, first two questions on the opposite side, you would get the same true shape every single time you do this. So there's the true shape once again of lamina ABC. And just put it in green just to show it. So we create an edge view, and if we look in perpendicular to that, we're going to see our true shape. And what we do is we just rabat it around. So the last method, we're actually going to use a second auxiliary plan then. So for the next one, I'm going to have to get a new sheet because it's actually a big enough kind of question being set up. So I'll just pause it again there, and I'm going to go through the last one. I'll just label that there. So this method 3, and this one is called an auxiliary elevation. So the auxiliary elevation is there, find our edge view, and then rabatment, basically rotating around flat till it's on the ground. Just pause the video there and I'll get the next. And the last one, method 4, this is going to be a second auxiliary. So second auxiliary plan. So same idea again, I'm just going to get the question set up. So I'm going to go once again 30 degrees for my vertical trace, 45 degrees for my horizontal trace, and then once again just draw random laminar in there again and just label them A, B and C and draw my elevation from that. Say A is there, B is there, C is there, and same idea, take B up, across and over. You'll probably be fed up by the time you're doing this, but at least it will have sunk in on how to actually project your points. So B is there, C, same idea again, C is out to there, and then A is taken out to here. So there's A, B and C, and connect them all together. So once again you can see I'm just making them up, but keeping just the trace at the same angle. So there's the elevation and plan of A, B, C, and once again I'm just going to use the green to show it, because with a second auxiliary plan we're basically going to be copying the same as the last method up to where we have our first auxiliary view drawn. So when we create an edge view. So that's our lamina ABC. So to draw an auxiliary view, you need to have an edge view of our actual shape there. So that's basically drawing an edge view of the plane, because this shape actually rests on the plane. Same idea again. You can say that's our lamina there, and it's on the actual plane, and we want to draw an edge view like that there, so that we can see basically our 3 points as an edge view. So what we need to do is get our 45, draw in extension there. This is going to be our new X1, Y1 line, and there's our horizontal trace on the ground there. There's a point. Got our vertical trace. Once again, take a height. It can be random. Just mark it in pink there. That height there. And we take it out, like the way I'm dotting it there. And then how tall is it in the actual view? Take the height there. Mark it off. And we're saying that height there, we'll call it H, the same as that H there. And there's an edge view of our plane. So that's an edge view of our plane. That means then that A, B and C is going to be on that. So B is going to extend out to there, C is going to extend out to there, and A is going to extend out to there. What we're saying then is there's an edge view of ABC on that actual plane. And the last thing we'll just rabat it around, taking it down to the second auxiliary. What you need to do is go perpendicular to your actual edge view then. So remembering for second auxiliaries, always measuring 2 views back. So if I look in there perpendicular, A is coming out here, C is going to come out here, B is going to come out here. I'll just move this up a bit. What I'll do is I'll draw in my new X2, Y2 lines. I already have an X1, Y1. There's my X2 and Y2. Let's extend these out. So, we always remember, when we take an auxiliary view, we step 2 views back. So for example, when I drew this auxiliary view here, that height H, same as that height H there, remember 2 views back. One view is our plan, second view our elevation. So I would have taken the height of H here, and I would have applied it to my auxiliary. If I show even B there, if I took that height B there, showing it there, mark it off there. And then the exact same now is going to be for the next one. So if I go 2 views back, one view is my auxiliary, my next view is my plan. So for my x1, y1, I take the distance, for example, for A, that distance there. So from the x1, y1 back to A, I step it out here. That gives me a new position for A. B, the exact same idea. There's B going back, x1, y1 back to B, remember in 2 views back, 1 view, 2 views. Go to B there, that's going to be B, and C then, take my distance from my x1, y1, back to C in my plan, mark that off out there. There's C, and when I connect A, B and C together, that gives me a true shape of my laminar surface once again, ABC. Now if you felt I was going too far off the page, you could draw a false XY line. So a false XY line would look something like this. Instead of measuring from there, you take a line parallel, for example, and you could mark it at B, where the height of B would be actually on the line. The distance from there when I go to there, and the distance from there when I go to there, and it'll give you more space inside the sheet. If you want to do that as well, it'll give you the exact same result, just to save space in the sheet. I've just copied for the sake of what's exactly in the book for anybody looking at that already. So there's the true shape of ABC once again. So put that in green there, and we'll do the last thing for finish up the video. I'll actually show you just how I got my heights and where I got them from again. So just show where I use pink there, just use green there. So the height of B here, that distance there, let's call that height G there. That's got from distance from there to there, from my x1, y1 back. Remember, going 2 views back. This is 1 view, this is 2 views. So I measure from our x1, y1. When we were drawing this initially, when we went 2 views back, our plan was 1 view, our elevation is our second view. So we got our heights from our elevation to draw that there, we got our heights from our plan to draw that there. So remember, always go 2 views back when you're drawing an auxiliary. It gets confusing, the more auxiliary views you do, the more confusing it may be, but just remember, go 2 views back. You just count them out, and it becomes easy then from there. And that was basically method 4. So you can see, even though there was 4 methods, 2 of them were very similar. The first and second one basically were the exact same, just showing 2 different ways of doing it. Either way, if you're happy with one over the other, that's fine. Method 3 was where we used the auxiliary and then rebatted around. And then method 4, what we did just there, this is a very common one to have for future questions and topics that we do where we use second auxiliaries. This is a very handy one to actually have. We'll be using this a lot in the future, and this is basically where we take a second auxiliary. So second auxiliary, and that's called plan. So hopefully that helps anybody who may have been stuck on that question there, or any of them ones. If you have any questions, let me know on Teams.